Good morning. I'm Nanang Alasutisna of Presiden University. I'm representing myself and Muhammad Munajat of PT Joyo Kusmo Margo Utomo. I'm presenting our research on design of hydraulic-driven road marking removal equipment. As an introduction, I'll share with you the study conducted by Department of Transportation of Indonesia regarding the road traffic accident causes. There are several causes of road traffic accident, and one of them is damage or pile road mark. To avoid further accident, this damage or pile road mark need to be replaced. However, the most widely used equipment for removing the road mark in Indonesia is operated manually, pushing by hand by the operators, and it is extremely not efficient, especially when it needs to remove the road mark of very long road. To cater that problem, we designed and built a more efficient road marking removal equipment that can be attached to a small truck or a pickup, and it is driven by a hydraulic power. In order to design this new equipment, we did a study of different road mark removal technologies. Amongst them, two methods are widely used in the world, which is grinding and water blasting. In Indonesia, the grinding is used by manual system, and therefore it is not efficient. And we propose a new technology which is using fast mill cutter with hydraulic power, and it is attached to a small trucks. The design methodology is presented in the following flow diagram. As a result, the existing equipment use a petrol engine with the power of 11.7 horsepower, and the cutter position is horizontal, and blade type is flail, and number of blade is 50, and feed rate of 4.17 meter per minute. There are disadvantages of existing road marking removal, such as takes a long time for road marking to be removed. The petrol engine is often break down. The belt frequently slip and the engine is prone to damage. There are a large number of blades needed, and it's only relied on weight of the equipment to damp the vibration and upward thrust. And because it uses horizontal flail cutter type, the removal is less clean. Next, we determining the power source of the road marking removal equipment. There are several consideration factors. First is the top of the power required to remove road marking. It can absorb shock loads from the removal process, resistant to dust from road mark removal, and there is an overload protection. And the size of the component is not very large. It can transmit power from the tailgate to the wiper blades. And the decision is to select the hydraulic power as it can meet the requirement, especially to absorb shock loads from a removal process and transmit power from the tailgate to the wiper blade. So the road mark removal cutter should meet the following requirement. Can remove road marking and concrete materials. It is hard on the outside and soft on the inside. Can remove road marking with a width of 150 millimeters. Can remove road marking with the thickness of 7 millimeters. And the selected cutter is the Fastmill WFX 12200R from Sumitomo. The existing one is using the flail it type cutter, where it has so many cutter blades in the grinding wheel. The new cutter will produce a cleaner surface. The next step is to calculate the power needed by the cutter. From the calculation, it is found that the power needed to drive the cutter is 10.678 kilowatt. Then calculation of hydraulic motors based on the rotation speed from the catalog, which is 750 RPM, and the torque is 136 Newton meters, the pressure is 130 bar, the flow rate is 50 liter per minute, and the displacement is 65.7 cc per revolution. And the selection of the hydraulic motor is Danfoss OMR 80 that has displacement of 80.3 cc per revolution. And the calculation of hydraulic pump resulted in a rotation speed of 2,500 RPM, which is from a catalog, and the torque is 136 Newton meter, and the pressure is 130 bar, flow rate is 50 liter per minute, and displacement is 20 cc per revolution. And the selected hydraulic pump is Parker Hydraulic Pump 0210 with displacement of 21 cc per revolution. And the reservoir capacity calculation resulted in 150 liters capacity. And the accessories needed to equip this hydraulic system such as check valve, flow control, relief valve, directional control valve, pressure gauge, filler filter, and suction filter. And this is the specification of this accessory system. Finally, the 3D CAD and working drawing is developed. To conclude, the cutter of this equipment use the surface milling cutter WFX 12200R from Sumitomo. The speed is 750 RPM. The removal rate is 13.56 meter per minute, 3 times larger than the existing system, which is 4.17 meter per minute. The hydraulic motor is Danfoss OMR 80 with the torque of 136 Newton meter and displacement of 80.3 cc per rotation. And the hydraulic pump is Parker 0210 with a displacement of 21 cc per revolution. The reservoir and the hydraulic accessories are determined based on design pressure of 130 bar and a feed flow rate of 50 liter per minute. For further research, we can suggest the automatic control of removal rate. In the existing design, the removal rate is controlled by the driver on the car, and it is not constant. The next suggestion is, so far we didn't consider the safety of the operation of this equipment. So for further research, it can be focused on how to operate the equipment safely. Thank you.